Okay, just a quick review of substitution. Remember, a system has two equations with two variables, at least two equations with two variables. And when we're doing substitution, our goal is to get one variable by itself. So if we have that set up for us already, that's awesome. And we look at the first equation, I don't have an x by itself on a side or a y, but the second equation does. I have a y by itself. So I'm going to box that off. These two things are interchangeable. Okay, so y is equivalent to 3x minus 10. Going into this equation that I haven't boxed off, any place I see a y, I'm leaving a blank in that place with a little parenthesis, and I'm going to replace that y with what it's equivalent to, which is 3x minus 10. What I love about this is now I have an equation that has all the same variable, and I can solve that. I'm going to first start by distributing to eliminate these parentheses. And when you distribute, make sure you're distributing the negative 6. Ooh, that should be an 18x. Ugly. And that's a positive 60. Now I just combine like terms. That is ugly, but it's negative 11x plus 60 equals 27. I'm going to subtract 60. I get negative 11x equals negative 33. And I get a positive 3 for x. To find y, I'm going to go in the box as the easiest place. You could use any equation that had both variables. And then you're going to get 9 minus 10, which is negative 1. And then my final step is to write it as an ordered pair. And that solution works in both of these equations and make them true. You could plug it in and give it a go. 3 times 7 is 21. Minus 6 times negative 1 would be positive 6. 21 plus 6 is 27. And 3 times 3 is 9. Minus 10 is the y value of negative 1. So it works.